LLM as a judge is one of these super powerful concepts, and I think in most GTM workflows, there is a place for it. When you think about why is data quality so important, one of the things that really sticks out to me is trust in data. You don't want sales teams to look at the wrong person because the LinkedIn profile URL was not the right one. And so many other downstream effects come from that. It's a very important data point, and I think without putting in the best effort to ensure accuracy of that, you're basically failing the task. And why should you listen to me? What I do in my data work is always run a sample set of data where I actually manually verify, is the result, a data point, or in that case, a LinkedIn URL, actually correct? And I would say the only way to really know is to do it yourself. But this is even the verification of the LLM as a judge output. So basically, was the verification correct? Because the verification can also be incorrect when the data point was right, but the verification says it was wrong, because then you filter out good results. That is also not something that you want. So in this case, and this is where the numbers come from, we get 75% of coverage for LinkedIn URLs. This is for a whole CRM, I think more than 50,000 contacts. I don't remember the exact number. And within those 75%, and this is the important point, this pipeline led to 98% accuracy. There would be more coverage, but with worse accuracy, which is really a bad result. So I take the 75% coverage, which more or less entirely depends on data availability in the segment of the market you want to find at. But within those 75%, extremely high accuracy. And part of that is the LLM as a judge concept. And I would show it very practically and hands-on. I'm showing this as a function in Clay, which means I develop the function once and I can run it whenever I need to execute this task. But this is not about functions. This is about LLM as a judge. So I'm quickly going to run through the pipeline leading up to a result. And then how does that verification agent look like? So because you have like certain input data, you need to transform the data so it's in the shape that you can start doing work with it. And this is here. Maybe we have a name, maybe we only have an email. So I'm reconstructing the name from the email. And then we basically have a domain, a company name, and we have a name for the person. And these are the inputs that we have. How do we get from here to a LinkedIn URL? There are many ways to do this. I would argue the worst way is take the email and look it up with the data provider, because most of the inaccurate results from this pipeline, 2/3, actually come from wrong data provider lookups and not from the agentic methods. This is how the pipeline goes. Let me actually make that a little bit bigger. We have agent 1, which is a Clayagent. I'm already digressing and go in too much detail, but like this is a really, really, really cheap Clayagent, GPT-4o Mini. The cost of this is, what is this? This is 1 penny, 1/100th of a penny. So this is less than 1/100th of a penny for results that already give you really good coverage, maybe 70%, but not all of them are super valid. So the ones where we didn't find a LinkedIn URL with that method, I actually do use a provider lookup. I use LinkedIn's Clay's LinkedIn waterfall, LinkedIn URL waterfall. I don't know if that's the right term, but anyways, that should output a few LinkedIn URLs. And from here on, I use a second agent that has full awareness of all the steps that have happened before, but uses a much higher end model. This is actually using Clayagent Argon, which is Clay's native model. It's a blend of LLMs. It's really powerful, 3 credits, relatively expensive, but also really good. It basically does a lot of work and is pretty smart. And this outputs LinkedIn URLs. What do we do then? I take these LinkedIn URLs, I enrich them, so we have input data, which says, this is some data we have. Then my pipeline tries to resolve a LinkedIn URL out of that. And if you enrich that LinkedIn URL, you have a new set of data. And you have the input set, and you have the intermediate output set. And how do I know this second set is actually the person of the input set? And as I said, I do these verifications manually. So I already built a pipeline that should give really good results at this point, which is what you just saw. But, and just to click into it for a second, this is the prompt for the second agent. And what you see, it's not your grandma's prompt. Of course, it's written by Claude Code, and it has like all these inputs. The previous agent reasoning is going inside of it. So it knows what has already been tried, what are the failure modes, yada, yada, all of this stuff. So this is like really bespoke to get to this point. But from here on, once I have the second set of data, I run this verification agent. It's actually not an agent because what I do in cases like this, I give it locally. Again, not your grandma's prompt. I give it locally all the data that I say it needs or that I determine it needs to be able to make a good, rounded judgment on data set 1, the CRM data, data set 2, whatever was found. I enrich that and then compare the two. And the idea is really first, and it's pretty simple to catch these stupid things of like whatever, typos, right? You find a Taylor Miller, but the real person has whatever, Taylor with AI instead of Y or something like that, right? These things you can catch with that. They should be caught before, but sometimes they slip through. But once you enrich that, you can see, oh, wait, this Taylor isn't that Taylor, and the data doesn't add up. And this is what that does. And a little trick here, I don't think you can do this all the time, but this is, for example, not using Clagent with web access. This is basically only ingesting the tokens that we have in this workflow that we have locally. And what that allows you to do is use a much higher end LLM model, because you don't have to read through websites or this or that. Maybe in some use cases you have to do that. But like in cases like this, it's really powerful to crank up the model quality because it will just make better judgments and you can give it much more structured, also much longer prompts, and it will still be able to follow those instructions really well. So this is kind of a little technical hack to make that really work. But what you see here is then, again, interrogating the two data sets we have, the input data set and the intermediate data set. Data set is really a fancy word, right? It's just the enrichment of the context, but ultimately it's a data set. And then you guide it to make the best informed decision, and you guide it what types of outputs you need. So this, what you see here, is of course elaborated over time. How do I build these types of agents? And that is meta prompting. You give it guidance, what you have, what you want. And this specific prompt is not, oh, verify the data. That is giving very specific instructions how I want it to look at the two data sets. And then, of course, you also want your output schema, because this all is meaningless if you don't output it in the right way into the CRM or the system of record. So you don't retry for all eternity, you know when this has happened, yada, yada, all of this stuff. But this is it. This is then in the end outputting a verdict. So here we have 9 verified and 1 review. This will get into a separate output pipeline, so to say, where the team then reviews, do we actually have the right LinkedIn URL? Don't we have it? And then they can promote it to the system. I was hoping to do this in 3 minutes. It became 10. There's no way you made it to the end of this. If you did, thank you so much. I hope this was useful. When you want to know more about how to build any of these individual pieces, you can subscribe. No, leave a comment and I would see that I can open the box of secrets a little bit more. Thanks. Peace.